So the point behind the notes today, and they won't be terribly long, is we're going to do the same exact thing we did yesterday, except we're just going to involve larger polynomials. So I'm going to take the biggest thing that you're going to see, which would be a trinomial times a trinomial, and we're going to take the same problem and we're going to show it using distribution, horizontal, using columns, vertical, and using the matrix or area model, okay? Just so you can see how it plays out. So this is still lesson 8.3. And so we're going to be multiplying polynomials and I'm going to say a mixture of bitrinomials. So we're just going to have larger polynomials that we're going to work with, and today's date's the 7th. So the original problem, let's do 2y squared plus 3y minus 1 times the quantity 3y squared minus 5y plus 2. So we'll start with the horizontal, or as I like to call, distribution. Let's do it in a color. Distribution. So we're just going to line these guys up. Actually, I'm going to color code them like I did before. So let's do 2y squared is one color. 3y is going to be a different color. And the constant is going to be a different color. Just so you can kind of track what I'm doing. And then the second polynomial just stays solidly colored. So what I'm going to do is multiply everything in the second polynomial by the 2y squared from the first polynomial. So I have 2y squared times 3y squared gives me 6y, and I'm adding 6y to the fourth. Now I'm going to multiply 2y times the negative 5y. Signs are different, so I get a negative. 2 times 5 is 10. Y squared times y gives me y cubed. And then I'm going to multiply the 2y squared times the positive 2. 2 times 2 is positive, 4. And then there's a y squared. So now I've done everything that I possibly can with the 2y squared. So now I'm going to multiply everything by the 3y. So I start with 3y times 3y squared. Well, 3 times 3 gives me a positive 9. Y times y squared gives me y cubed. Then I have 3y times negative 5y. Well, that's just going to give me negative 15, and the y's add up to give me y squared. And then I have a 3y times a 2, and that gives me a positive 6y. Now, where it gets tricky, remember, is watching signs. So I'm going to multiply everything in the second polynomial by a negative 1. So actually, all that's going to change is the sign, because multiplying by 1 is not going to change the value. So that's going to make the 3y squared a negative 3y squared. It's going to make the negative 5y a positive 5y. And it's going to make the positive 2 a negative 2. Okay? Now the fun bit is we got to look for like terms. So I'm going to circle up. Let's see. We have nothing but 6y to the fourth is it, so he stays as 6y to the fourth. So he's all alone. So let's look at y cubes. Let's see, there's a negative 10y cubed, a positive 9y cubed, and that's it. So we add up negative 10 plus 9 is going to give us a negative 1y cubed. So I just write negative y cubed. Now I'm going to look at squares. Let's see, there's a positive 4y squared, a negative 15y squared, a negative 3y squared. So 4 minus 15, that's negative 11. Negative 11 take away 3 is negative 14. So negative 14y squared. So notice that the individual variables do not change. Then we've got a positive 6y and a positive 5y for a total of a positive 11y. And then we have the lonely constant minus 2 at the end. So there's your answer, very colorful. 6y to the fourth minus y cubed minus 14y squared plus 11y minus 2. Okay? So, a little longer, things spread out a little bit more trying to find the like terms. So let's do it now, but columns. Now, because my two trinomials are the same length, it doesn't matter who goes on top. But for our purposes, like we did last time, let's take that front one and let's put it at the bottom. So let's put so this is going to be the vertical method, which I like to call column multiplication. And we're going to put the 3y squared minus 5y plus 2. Now, if you have two polynomials and the values don't match in terms of their exponents, it doesn't matter. It's kind of like multiplying a 3-digit number times a 3-digit number, ones lines with ones, and so you just take the last digit, line it up with the last digit. So in this case, we don't really have an issue here. So I'm going to color code again. We'll make 2y squared blue. We're going to make positive 3y. We'll make it green this time. And then we'll keep negative 1 as purple. So what I'm going to do is multiply everything on top by the purple negative 1. So negative 1 times 2 is negative 2. Negative 1 times negative 5y is positive 5y. Negative 1 times 3y is negative 3y squared, or 3y squared. I'm going to probably run myself out of room, so I'm going to have to be a little bit daintier. So next time, I'm going to multiply the green 3y by everything on top. And again, I make sure that I write the product under its matching term. So 3y times 2 is a positive 6y. That lines up underneath the 5y. 3y times negative 5y is negative 15y squared. And then 3y times 3y squared is 3y to the fourth. Or 3y cubed, sorry. Come on, brain. Whoop. All right, now I have to be very dainty with the blue, but we will make it happen. So I have 2y squared times 2. That's going to give me 4y squared. Positive 4y squared. So I line up like terms. I'm sorry. Oh, yeah, thank you. Yep, 3 times 3 is 9. All right, so then 2y squared times negative 5y is going to give me negative 10y cubed, and I line up my y cubes. And then 2y squared times 3y squared, and here's where I'm going to be really rotten and scrunch it in the margin here if I can, 6y to the fourth. So now what I'm going to do is add these up. So I'm going to scrunch things over a little bit. So I get 6y to the fourth. I have 9y cubed minus 10y cubed is negative y cubed. I have negative 3y squared, negative 15y squared, for negative 18y squared plus 4y squared gives me negative 14y squared. 5y and 6y is 11y, and then I have the minus 2. So the advantage to this method is that like terms are right underneath each other, and it's easier to combine them. Okay, so I actually find the longer my polynomials, I kind of like this strategy a little bit more because I have so many different terms to combine. It's a little easier when they're side by side. So last one, same idea. Let's go ahead and do the area model, or what I like to call the, oops, let's give it a prettier color than that. Let's do the matrix. So the matrix is what is the area model, and I'm going to rewrite our two polynomials again. So it's 2y squared plus 3y minus 1, that times 3y squared minus 5y plus 2. So the big thing about the matrix is we got to figure out how big to make our box. So we figure out how many terms we have in each of our polynomials, and that's the size of the box. We're going to have a 3 by 3 box. So how many little boxes am I creating? I'm going to create a total of 9 boxes. Okay. Now, remember, if you choose this method, you don't have to tell me what you're multiplying to get the area of that individual rectangle. I just do it in our notes so you can see what's happening. So we're going to take 2y squared, positive 3y, negative 1, and I'm going to put that down vertically. And then across the top would be the 3y squared, the minus 5y plus 2. So each term in each polynomial gets to be associated with a box. And then what we do is just calculate what the area is of each individual rectangle. So for this upper left rectangle, we've got 2y squared, and we're going to multiply it by the 3y squared, and we get a total of, I'm going to just do a red color for the whole thing, 6y to the fourth. And then for the next one, we're going to multiply 2y squared times the negative 5y, and we get negative 10y cubed. And we're going to multiply, excuse me, 2y squared times 2, and we get 4y squared for that area. And we're just going to continue on. So let's do 3y times the 3y squared. And that's going to give me, and when I'm doing this, I should be adding signs, so this one should be a positive 4y squared. This is going to give me a positive 9y cubed. And then 3y, oops, sorry, wrong color. Come here, you. 3y times the negative 5y is going to give me the negative 15y squared. And then 3y times 2 is going to give me the positive 6y. Now we're going to multiply everything by negative 1. Figure out the dimensions of each of those rectangles. So we just take the length and the width of each of them. So if we negative 1 times 3y squared, and we get negative 3y squared. And we take negative 1 times the other dimension, which is negative 5y. And we get a positive 5y. And then we have negative 1 times positive 2, and we get a negative 2. So where did I say we should be looking for like terms on the diagonal? And look what happens here. We have, oops, I messed that up, didn't I? That should be a like term. Yeah, this one's supposed to be a y cubed. Sorry. Nobody said anything. So, there we go. Now that makes sense. So, this diagonal, we have y cubes. Okay. On this diagonal, we have y squareds. On this diagonal, we have y's. So we're just going to write it out. And again, we're still kind of doing that z fashion, but it kind of zips back and forth because we got to go from here through here, and then here, and then here, bam. So it's a weird looking z thing. Okay. Now I'm going to erase that because that's ugly. Okay. So we start with the 6y to the fourth. And then we've got negative 10y cubed and 9y cubed, so we've got negative y cubed. We've got 4y squared and negative 15, so that's negative 11y squared. And then negative 3y squared for a total of negative 14y squared. And then 6y and 5y is 11y. And then we have minus 2. So again, what I kind of like about this is there's a visual connection between like terms, whereas the only one that doesn't have that connection between like terms is the distribution method. Okay, so that's something to keep in mind of what you choose to use for your homework. All right, and that's it.
Do we just start our homework?